I will present today with Carayon. The second point is to thank the organizer to invite me to give this talk. And the third and final point of my introduction is for Paolo Antonio Pirazzoli in memoriam. We should remember that Paolo, since the early 70s, was interested to connect fish tank archaeology to relative sea level change. For example, at Luculus fish tank, Paolo Pirazzoli demonstrates from the work of the Archeological capella that the lower footwalks are below the opening for water arrival. So if you don't take this into account, you can overestimate relative sea level change since the last 2,000 years. Second case studies at Formia. Pirazzoli has verified that the lower footwalls was also always submerged because it is below or it corresponds to the level of the sliding roofs for the Swiss gates. So there is no other option that the lower footwall is generally infratidal and not mid-tidal. Third and final case study published by Pirazzoli is that the conclusion are that the upper part of the mid-tidal sliding roofs generally ended not at the lower footwalls but at the level of the upper footwalls or upper capilli, where the gate could be easily used and walked. So, assuming that the top of the upper footwalls was high enough above high tide to prevent flooding by sea surge, this archaeological indicator can be used as a reliable and precise sea level indicator. So, in conclusion of this first part of the talk, what we have to remember of Pirazzoli's work? Maybe first element, that usually most of the time, archaeological indicators are accurate but are imprecise to measure relative sea level change. And the second element is in connection with his publication in Science in 1976, he was able for the first time to link archaeological structure to biological zonation and to provide sea level variation measurements in the northwest Mediterranean during Roman time of about 50 centimeters in so-called tectonically stable area. Since more than 30 years, since my PhD in the early 90s, I have tried to follow this simple and multidisciplinary methodology connecting geomorphology, biology, on benthic organism, and archaeological along the Mediterranean shorelines. Here, for example, it's the Plage Verne excavation. It's a post of wood from the 3rd century BC, and you can see that from the top to the base, you have some supratidal notches. You have the upper limit of the barnacles, so you have a very precise, with very good precision, the upper limit, the former biological mean-sea level, which is well dated by archaeological artifacts. In this case, the precision is absolutely fantastic because we are dealing with an artificially protected harbor basin, and it's well protected from the surge, from the swell, from the tempest, from high energy event, and so you have a precision of plus or minus 5 centimeters with a very good chronological time control. This biological zonation along waterfront structures in the past can be correlated and compared to modern analogues, like here in Toulon harbor, you have by low water pressure the upper limit of barnacles, in this case Balanus amphitrite, which correspond to the biological mean sea level and can be compared to past former sea level. It's by using this quite simple methodology that we have been able, step by step, structure by structure, period by period, excavation by excavation, to produce quite precise relative sea level index point and relative sea level curve. Here in Marseille, along the Greek quay, founded around 575 years and abandoned 50 years later, around 525 BC, you can see and you can follow for 15 meters the upper limit of the barnacles Balanus amphitrite at minus 70 plus or minus 5 centimeters below the zero NGF or below mean biological sea level. It's, for me, the only way to produce precise data. I would like to highlight two elements. The first element is that all the waterfront archaeological structure in connection with the Mediterranean Sea are characterized by biological zonation. So it's something that is very general. You analyze the archaeological structure are paleocliff. First point. Second point, it's very strange that this methodology has been completely neglected in the last 25 years. And I don't understand why this technique, which is quite simple, has been so underused. Each time you have a structure like we saw in Falasana, in Carayon, in Byzantium, in Portus, in Marseille, in Alexandria, you will find biological zonation. For example, here a good case study in connection with the earthquake of 2003 at Boumerdes in northern Algeria along the Camellia coast. A study that we have done with Mustafa Bekawi from Strasbourg University. You can see the uplift of about 25 to 30 centimeters due to the co-seismic movement, and you can see it along the rocky cliff of Camellia, and you can even follow it along the uplifted breakwaters of Delis in Camellia. The green algae, the red algae, have been killed and have been transformed into this whitish zone. So it's quite easy to follow by helicopter or by fieldwork. On this third part of my lecture, I want to develop briefly two case studies that have been quite recently analyzed by a multidisciplinary team in France, in Fréjus, in Provence, and in Naples, in Languedoc. In Fréjus, it's a fish pond, very special fish pond, that have been excavated by the team of Pierre Escoffon with the help of Stéphane Bonnet, geomorphologist, and the fish pond from Kipling is still visible and is well dated from the 1st century AD. I'm happy to thank Pierre Escoffon and Stéphane Bonnet for their hard work. As you can see, during the field work a few years ago, it was difficult due to the depth of the excavation and the problem of the water table. On this image, taken from Fréjus Kipling fish tank excavation, you can see two main archaeological elements that can be used to measure sea level change. On the top, you can see infratidal gates that have been always below the the sea level during Roman times to allow the passage of water between two rooms of the fish tanks and to avoid the fish to escape. And you can see on the lower left part of the slide sluice gate in wood. What was very interesting to measure in Frejus Kipling, it was the difference between, for example, the upper limit of marine organism up to minus 40 centimeter below NGF, below the zero, with a precision of 10 centimeter. You can see on the upper left side Cladocoras espitosa, or you can see some typical marine bivalves of marine microfauna incrustating the wall of the fish pond, and they are about 1 meter above the channel and the gates, which are going down to minus 120 to 150 centimeters. So what is the conclusion for this first case study in Frejus, and that we publish, if I remember well, in the International Journal of Geoarchaeology? We have almost the same mobility of the relative sea level in the last 2,000 years between Marseille and Frejus. Maybe a little bit slightly lower in Frejus, which is quite paradoxical, because step by step we are approaching the Alps arch, and we should expect some elevated sea level indicators like in Antica or in this studied by Michel Dubar a few years ago. Second case study I want to highlight, it's in Narbonne, on the coast of the Languedoc. It's a very nice excavation that has been directed by Corinne Sanchez from CNRS, and my two colleagues, Nicolas Carayon and Clément Flo, co-authors of this presentation, work on Lanotic fish pond. Here you can see a linear image of the sector of this northern and oblique aerial image of the northern part of this Paleo lagoon and Paleo Gulf, and you can see quite easily the lake of Capelle, which is the former fish pond, circular, at the base of a Pleistocene terrace, an outcrop, Marley outcrop, and Marley Miocene limestone. Nicolas Carayon, archaeologist, and Clément Flo, geomorphologist, with the team, excavated extensively the fish pond of Narbonne, Port-la-Nautique, the fish pond of Les Capelles. And they demonstrate, first of all, the chronology. The fish pond is well constrained by chronology between minus plus 10 Anno Domini. So 40 years of use, first element. Second element, the size of the fish ponds is very close to the imperial fish pond of Sperlonga or the fish pond of Lucullus at Circeo. So for them, it's a fish pond that has been used of very close family, close to the emperor. So, but myself, I am more interested in the chronostratigraphy and the biological zonation and archaeological zonation that you can follow all around the border of the fish pond. You see here some strange amphora holes and a gate which allow the passage of the water. These amphora holes are in connection in a law to permit the fish to be protected. It's something like a hose. Here you can see some details of the excavation with the fixed gate, infratidal fixed gate, and the amphora holes all around the circular limit of the fish pond. As you can easily understand, I was very well interested in this fish pond because you have a nice archaeological zonation with amphora that must be immersed by seawater, and by chance they were also a biological zonation. Here you can see some pliosaur, marine or lagoonal animals like Conopeum serrati or Cryptosula paliasana, which are typically parallel bryozoaire, and the upper limit of the bioconstruction corresponds to circa 60 centimeters below zero NGF, 2,000 years BB. Here a more global view of the part of the excavation. The upper limit of the marine incrustation and the upper limit of the horizontal amphora for fish nesting. So now let's try to make a conclusion concerning Narbonne. If we compare the data in blue, red and green of the archaeological zonation mainly and compare with the curve that we obtained with Laborel in 84, 93 and with my PhD in Marseille, we see that there is a close correlation and that in Provence and in Narbonne, usually, except along the Alps between Antibes and Nice, the sea level modification, the sea level rise since the Roman period, since 2,000 years, have been very small. My colleague, when he was working in Aix-Marseille University, Matteo Vacchi, was making a very nice work of filtering and standardizing all the data published between Nice, Toulon and Alicante. And he was able to show in 2016 with the team that the sea level are almost similar from Costa di Levante in Spain and Provence, with relative sea level stabilization in the last 6,000–7,000 years, which is general and is in connection with glacial-static change. And again, a focus on the Vacchi work synthesis. I think there is more than 150 radiocarbon dates and archaeological dates showing quite well the relative stabilization in the last 6,000 years BB. So what I would like to say in conclusion is that from an archaeological point of view, the sea level question is not crucial. There is much more important problems to solve in an archaeological excavation from a geoarchaeological context. For example, the sedimentary budget, the coastal deformation, the pollution, the complexity of the Anthropocene and the Paleoanthropocene. So sea level is not a major forcing agent since the classical period, except in very localized points which are of interest from a geological and geophysical point of view. Last point and last slide, it's the question why the biological zonation is an indicator which is quite systematically neglected. There is maybe one hypothesis. Archaeology is a slow science discipline. Geology is usually a speed science discipline. So there is a problem, I think. I think physical geomorphologists or geologists are not interested to wait for months and for years in order to analyze structure that will appear layer after layer of excavation. So maybe this is the elements. This is the first element. The second element is, as we can see, in Sidi Daoud, fish pond, Roman fish pond, in Cape Bon Peninsula in Tunisia, we can see that most of the fish ponds studied and that will be presented in the field or probably in the presentation today and tomorrow are submerged or semi-submerged structures. So they have been cleaned. The original biological zonation vanished since 2,000 years, cleaned, bio-eroded, and this is probably the elements. And the third point I want to say, and the final point, I recall the elements, the teaching elements of Paolo Pirazzoli, who was always very precise, because he was educated as an engineer, and he taught us the research looking for precision and not to do things too quickly. Thank you very much for your attention, and I apologize again for my absence.